Alright, so what I want to do is I want to show you guys, I believe, 4 different problems on Chapter 12 homework and show you where the most of the mistakes on the homework were made. Alright, so the first one we're going to look at is question number 54. And question number 54 asks you to name this compound and also asks you to classify it. Okay, so before even looking at this, the biggest error that people did was that they said that this was carbon number 1 because it was bound to the OH. Remember, you always want to find the longest chain involving the function group. So this is going to be 1, 2, 3, 4, 5, 6, 7. So we have heptan all, and the OH group's going to be on carbon number 2. So we have 2 heptanol. What other things do we have? Well, we have an ethyl group at 5. We have a tert-butyl group at 4. And we have a methyl group. That's carbon number 6. So now, in order to finish this out, what we have to do is put these 3 things in alphabetical order. So remember, we alphabetized the B, not the tert. We alphabetized the E for ethyl and the M for methyl. So we're going to have 4 tert butyl, 5 ethyl, 6 methyl, 2 heptanol. Alright, so that's our question there. We named it. Now we have to classify. So go and put your semicolon. You know it's an alcohol. This alcohol, the carbon of the alcohol is bound to 2 other carbons. So this is a secondary. So it's a secondary alcohol. Okay. So that is going to be question number 54. So let's see, what was the next question people had problems with? So the next question people had problems with was 53. 53 looked like this. So from chapter 11, we can see that this group right here is the phenol. Notice it's OL because it's a compound. So that's our base group. And remember, whenever you do a base group, wherever that substituent's in the bases, that's going to be carbon number 1. So we have 3 FLUORO phenol, so 3 fluorophenol. We can also call this meta fluorophenol or M fluorophenol. Okay, so there's 3 ways, 3 correct answers for this. But the main thing you had to do is figure out that the base name was phenol. Alright, so what about another one? Okay, so number 50. Alright, you guys apparently love 50. Alright, so what 50 was a dehydration reaction. C6H5, that's a C, C6H5 with an OH here. So the first thing you want to do is draw this all out. Ooh, C6H5, okay, C6H5. Actually, I'm just going to do this. Let's make it clear. Alright, drawing on the pen is actually more difficult than it looks. Alright, C6H5. Alright, so C6H5. So if we redraw this, we have our aromatic ring here. Okay, and we have an OH group. Now this has H2SO4 and heat. So knowing that we have an alcohol, we have a tertiary alcohol in the presence of acid and heat, we know we're going to make an alkene. So it's a dehydration reaction. So a dehydration reaction making an alkene because it's an alcohol in the presence of acid and heat. Why is this not making an ether? Because you don't have a primary alcohol and it's not 140 degrees. Remember, to make ethers you need both of those. All right. So remember, this is our alpha carbon. Here's our beta carbon. Here's our beta carbon. And here's our beta carbon. Alright, so we have 1 beta carbon, 2 beta carbons, and 3 beta carbons. Now, if we want to get really specific here, we can see that there's a plane of symmetry that runs right through this compound. Okay, so we can see that this beta carbon and this beta carbon are equal. All right, they're equal. Now again, we have 2 hydrogens coming off that beta carbon. Now what about this carbon? This carbon is bound to 1, 2, 3 other carbons, but there are 4 bonds. So there are no hydrogens here. So you cannot put a double bond here. All right, so that means that our compound, all right, is going to look like that, and our double bond is only going to go in one of those 2 locations. All right, because this compound and this compound are the same. All right, are the same. So you're only going to get one. Some people put this compound as the answer. Now, why is this not the correct answer? Again, there's no hydrogens here to remove, so you can't put the double bond here. Plus, once you do this, once you do draw this, notice you have 5 bonds. All right, so you're breaking the biggest rule in organic chemistry, putting 5 bonds to carbon. So we only have one product, all right, because of the symmetry. Those 2 are equivalent, and it can't go here because you're going to put 5 bonds there, and there's no hydrogens. All right, so that is question number 50. Okay. So let's look at question number 46. All right, so this is the last one, 46. All right, so 46 we have 3 isopropyl, 1 octane, and we have selective or mild oxidation. All right, so oxidation. So let's look, what is this selective or mild oxidation? Well, remember you can have MnO4 or Cr2O7, so permanganate or dichromate. So anytime you see mild oxidation, those are the 2 reagents I want you to think about. Now, in order to get to the product, we have to draw this out. Alright, so 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, we have our 3 isopropyl, octanol. Octanol. Okay, so here's 3 isopropyl octanol from question number 46. We're going to oxidize it. We can see here from the structure it's a primary alcohol. And what it's going to do first is it's going to first make an aldehyde. Okay, so one, 2, 3, 4, 5, 6, 7, 8. Alright, so this is an aldehyde. Aldehyde. Alright, now aldehydes do not sit well. They're just going to continue to react. Alright, so they're just going to continue to oxidize. So selective mild, you cannot stop it at this aldehyde. So it's going to continue and it's going to make a carboxylic acid. Okay, so this now is our product. Alright, so we have a carboxylic acid as our final product. Okay. One thing I do want to show you is notice we're oxidizing a primary alcohol to an aldehyde and then to a carboxylic acid. We can also, alright, let me grab another color here. We can also do a reduction. Alright, and we can reduce aldehydes to alcohols. So what are some reduction reagents? Well, we have H2PT or Ni. That's one. We can also use lithium aluminum hydride. Alright, that's another one. Or NaDH. Alright, so there's 3 reagents here we can use to go backwards. Okay, so it's the same exact reaction but in opposite direction. So primary alcohols are oxidized to aldehydes and then carboxylic acids. We can reduce aldehydes using one of these reagents back to alcohols. Alright, so notice the reaction goes back and forth, just depends on what the reagent is. So we can go a little bit further with this and just really dive deep into the sticks. All right, so we can take ketones and we can make secondary alcohols. All right, in order to do this, notice you're going from a carbonyl to an alcohol. All right, to do this, you need to use a reducing reagent. Okay, well, we can go from alcohols back to ketones through an oxidizing reagent. Again, just using one of these oxidizing or reducing reagents. Now remember that tertiary alcohols cannot oxidize to anything, and neither can phenols. Okay, so we have some yin and yang. All right, these guys don't. These guys do. Ketones go to secondary alcohols go to ketones. You just need a reducing or oxidizing reagent. Here, primary alcohols, oxidized aldehydes, and then the carboxylic acids with some oxidizing agent. And we can also reduce aldehydes back to primary alcohols. Okay. So anyway, so this is getting into a little bit of the next chapter that we're currently in right here, but I really want to show you how these two chapters are really alike in terms of reactions. All right, thanks for listening, guys.